Uh, Hi again. This particular problem has several options. Decide which situations represent exponential growth, exponential decay, linear increase or decrease, or none of these patterns. For A, the value for a rare bottle of wine goes up $50 each year. It's a constant increase each year, and it is linear increase. B, the value of a piece of sculpture increases by 15% each year. Percentage increase, so I have here exponential increase. A three-year labor contract calls for yearly increases of $80. Linear increase. A 3-year labor contract calls for an increase of 5% the first year, 4% the second year, and 3% the um, third year. None. There is not in this ratio is not constant. None of the patterns. E. The value of a car drops by 40% each year. Exponential decay. F. The average cost of a home computer for the first-time buyer has been dropping by $300 each year. Linear decrease. G. The number of new cases of a disease reported over the last decade has been dropping by 12% each year. Exponential decay. Next problem I'm going to work on is in 1940 there were 6,102,000 farms in the United States. By 1997 the number of farms had dropped. So let's say let me erase this really quick. Okay. Letting t equal 0 in 1940 gives me the data points of time and number of farms. And 57 years later, number of farms. Then with the model, y is equal to kct. Using this point, k c to the power 0. This is 1. So from here, k is equal to 6,102,000. So now my model is c to the power t. Alright, now I need to find c, and I'm going to use this point. Y is equal c to the power 57. T is 57. Now from here, 1,000,000 912,000 divided by 6 million is equal to c to the 57. So c is 57th power of over, and this is approximately 0.9798. So the equation of the function is 6,000,000 0.9798 to the power t. This is the answer for A. B. Use your model to predict the number of farms in 1980. In 1980, from 1940, t is 40. So y is equal to 0.9798 to the power 40. This is approximately 2,697,551 farms. Predict the number of farms in 2005. In 2005, t is 65. So y is equal to, oops, 6,100,000, 0.9798 to the power 65, and this is approximately 1,619,591 farms. If the trend continues, estimate when there will be 1 million farms. And so y is given the output. So I'm going to say here 1 million is equal to the power t. So from here now is 0.9798 t. Here again, if I want to solve algebraically, I'm solving it because we studied section 2.6. So then I'm going to take log of oops, now I'm not going to rewrite this, t log here, and then t is equal to log this one over divided by log of this value 0.9798. This should be here approximately 88.63 years. So to answer E, You can say there will be 1 million farms in about 88.63 years after 1940. That is the mid 2029. Next question. The level of population in the Great Lakes is a major concern. A. In Lake Erie, about 38% of the pollutants are washed out each year. So, decay factor is 1 minus 0.38, which is 0.62. So then if I say this is P sub 0 is my initial amount of pollutants, the equation becomes 0.62 to the power T. B, how long will it take for 90% of the pollutants to be washed out? If 90% of the pollutants is washed out, then 10% of the pollutants remains. So you want, the question is T, what is T, when 10% of the pollutants remain. P sub zeros cancel out each other, and 0.10 is equal to 0.62 T. And I graphed it, and let me see. This is your y1, and this is your y2, and you're looking for the intersection of the two. And I use the window 0 to 10 and 0 to 1 with increments of 0.05. Because of this value here, it's very close to 0. And so if you graph, and then now I want second calc, the intersection value, enter, 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 and enter. So from here, the approximation is 4.8. Time is 4.8 years. So it will take about 4.8 years for 90% of the pollutants in Lake Erie to be washed out. If you wanted to solve this algebraically, from here, this is what I would do. I'm going to take log of both sides, then T of log 0.62. From here, T is equal to log 0.10 to log 0.62. This should give you 4.8 years. C, how long, about 0.053% of the pollutants are washed out each year. If no further pollutants are added, write a function to model level of pollutants. So then 1 minus for y is equal to P sub 0 0.99947 to the power t. Now to answer D, uh, how long will it take for so 90% will leave 10% of the pollutants. Then these are cancelled out. Then from here, 0.10 is equal to 0.99947 T. So I'm going to take a shortcut here. Your T will be log 0.10 to log 0.99947. Let me do this calculation. Log 0.10 divided by log 0.99947. 4,043.3 years. Last question. According to a medical study, the half-life of kidney transplants was 13.3 years. So write a formula for the exponential function that can be caused to model the percentage of kidney transplant recipients who haven't rejected the kidney as a function of time. If I say, let's say R sub 0 is the initial number of kidney transplant patients, then R of t as a function of time is R sub 0 c to the t. And because it's half-life, half of R sub 0 is R sub 0 c to the t. R sub 0's simplify each other. Okay. So if the number of years is 13.3, so 1/2 is equal to c 13.3, right? So from here, c is equal to 13.3 power 1/2, and this should be approximately 0.9524. So an exponential function that can be used to model the percentage of kidney transplant recipients would be R of t is equal to initial decay factor to the power t. B, what percentage of kidney transplant recipients do you predict will still have in 10 years? So R of 10 is equal to R sub 0 0.9524 to the power 10, and this is equal to, this calculation is approximately 0.6140 R sub 0. So the percentage of recipients still having new kidneys is about 61%. C, how long will it take until the percentage of kidney transplant recipients having their new kidneys will be down to 20%? So R sub 0, 0.9524 T is equal to 0.20 R sub 0. R sub 0 simplify each other. From here, T log 0.9524 is equal to log 0.20 So t is equal to log 0.9524 will be approximately 33. So it will take about 33 years until the percentage of years until the percentage of kidney transplant recipients having their new kidneys will be down to 20%. Or using my calculator, I'm going to, this is your y1 and y2 is 0.20. So let's go to y. What I'm going to type here is 0.9524 to the power x equal 0.2 graph. Let's extend x and x max, let's make it 50 graph. Alright, now second calc, go to 5, first curve, second curve, intersection. It actually gave me like a second ago. It didn't ask me guess this time, so let's do it again. Second calc, 5. Let's go. This is your first curve, second curve. Now it asks me guess 33, which is the value we obtained. Alright, I'll see you next video. Thank you.